about mixture, element, and compound in continuation to what we had started. But before we talk about this element, I would like you people to subscribe, like, and share our image or the videos with others so that they can also gain the information or the knowledge that we are imparting onto you as a subscriber. Thank you. So, the element. We're going to talk about the elements. Now, elements, these are pure substance that cannot be split into a simpler substance by chemical means. So you can say these are pure substance that cannot be broken down or split into simpler substances by chemical means. Now, so from the definition that we have just described above here, the elements are obtained from simpler substances that are known as an atom. Now, we need to know what is this atom that we're talking about, or this simpler substance that form this given element, an atom. So atom, it is the smallest particle of an element that takes part in a given chemical reaction. What about it? We're saying it is the smallest particle of an element that takes part in a given reaction. So for instance, if we take a paper and we cut it or we split it into tiny pieces, the tiny pieces are the atoms. So if we bring these given tiny pieces together, they will form an element. That's why we are having first 20 elements or more than 20 elements in a periodic table. Now, from the atoms now, we are going to talk about the subatomic particles. So, subatomic particles, we are going to define what are subatomic particles. Subatomic particle, these are the smallest particle of an atom. So you can write the saying, these are the smallest particles of an atom. So you obtain the atom from the subatomic particle. Okay. Now next one, we're going to talk about examples of subatomic particles. Examples of subatomic particles. Number one, we are having proton. Number two, we are having neutron. Number three, we are having electrons. Okay, from this one, the next thing that we're going to talk about or elaborate more on are the charges of the subatomic particles. So charges of subatomic particles. So we are going to talk about the charges of subatomic particles. Charges, from the term here, charges means the particles can either be positive or negative, or others ending up to have no charge. So we are going to talk about one. Let us start with the proton. Proton, it is always positively charged. So it is positively charged. Bracket can write to represent that positively charged. So we go to the next one, which is the neutron. Neutron, it has no charge. It doesn't have any charge with it, so it is neutron. So the third one, we are having something like electrons, which is negatively charge. So you can write that to represent negatively charged. So from here, I think now we are having an idea about what we're talking about the subatomic particles in accordance to their charges as one of the particles, smallest tiny particles that form an atom. Learn about the subatomic particle. Now we can still come back to the elements whereby the subatomic particles are the ones that are forming elements. Now from the elements now, because it is a pure substance that cannot be broken down into a simpler substance by chemical means, we are going to talk about the examples of the first 20 elements. Now, from what we're having here, we're having examples of the first 20 elements, and as we name them, we are also going to consider their symbols. So the first one is hydrogen, whereby the symbol is capital H. The second one is helium, whereby you're having capital H and E. Then you're having lithium, capital L and I, small I. Beryllium is capital B and small e. Boron is just a capital B. Carbon, capital C. Nitrogen is a capital N. Oxygen is a capital O. Fluorine, capital F. Neon is a capital N and E. Sodium is Na. Then magnesium is a capital M and a small g. Then you're having aluminium, capital A and L. Then you're having silicon, Si. Come to number 15. So that really is the order on how the elements are arranged. Come to number 15, phosphorus. It is capital P. Then sulfur, it is S. Chlorine, capital C and L. Then you're having argon, it is Ar. Then you're having potassium to be K. Then calcium to be Ca. So these are the symbols of the first 20 elements into consideration. As we learn about these given examples of the elements in the periodic table on how they are arranged according to electron configuration or electron arrangement, we need to know the order in which they are arranged and the symbols, so that whenever we are writing electronic configuration, we're going to use these given elements in order, so that you can be able to identify specific number when you're drawing the electronic configuration. Any question in relation to what we've just talked about, you can comment. But from what we've just learned, you can share, subscribe, and like the video that you're having. Be blessed.